Alright guys, so this is, I believe, page 8 of your packet, and so this is the first time that we're actually going to really go into great detail about a specific type of reaction. And we're specifically going to be going into detail about synthesis reactions. So I want to give you a little bit of a background before I get started. So you're going to see a couple of symbols that I just want to clarify what they are for you. First of all, M. Whenever you see M, what that represents, what that stands for a metal. Okay, so in any of these reactions, if you see just M all by itself, that represents just a metal. Alright, while NM obviously stands for a non-metal. Alrighty, how many products will you always make in a synthesis reaction? So what we're thinking about, go back to when we were reviewing synthesis reactions in general in the context of all 5 of the different types of reactions. And what you should remember is that when you take one element plus another element to get one compound, that is a synthesis reaction. So no matter what happens for a synthesis reaction, you will always only get one product. Alright? Now, just to clarify, I'm going to give you a little bit of a background about bases and acids, okay? Because we're going to be talking about, I'm going to be introducing them for the first time in this section, in this little video. Okay? Bases are going to be compounds that end in OH. So if you see any compound that has an OH at the end of it, that is automatically going to be a base. While an acid always begins with an H. There are a couple of compounds that begin with H that aren't acids, but most of them, pretty much anything that begins with an H, almost all of them are going to be acids. Alright, and I'll show you how that plays into what we're about to do right now. Alright, so at the top of your page, unfortunately it's not on mine, but at the top of your page you have 3 different types of synthesis reactions. Alright, you have the classic 1A, which is just one element plus another element gives you a compound. Alright, then you have your 1B, which is your water plus your metal oxide, and I'll show you what that is in a second. Okay, gives you a base, alright, and then your non-metal oxide plus water gives you an acid. So I'm going to show you how each of these forms, I'm going to do a couple of them with you, and then I'm going to ask you to complete the rest on your own. Alright, so let's look at this, for example. Let's look at the first one. I've got Al plus O2. So your first task is to decide what type of reaction this is, whether it's 1A, 1B, or 1C. Alright, so since you don't see any water in this reaction, you can automatically eliminate 1A and 1B and 1C. You know it's not 1B and 1C because you don't see any water, so it's got to be 1A. Alright, so you know that here's one element, here's a second element, you know you have to form a compound. So here's the tricky part. You're going to form a compound with Al and O2. Okay? And specifically in your compound is just going to be Al and O. And so yes, it's going to be an ionic compound, and yes, you have to cross your charges. So if you never learned how to make an ionic compound, or you kind of eased your way through it and didn't really truly learn it, you're going to be in deep water. So watch now as I reteach it really quickly, alright, and you'll be fine. So Al is going to go first since it has a positive charge. The positive always goes first, so Al, okay, and Al has a +3 charge, so I'm going to just write Al3+. Okay, then I have oxygen, and the only reason why there's the 2 there is because oxygen is diatomic, so by itself it can't be truly by itself, but in a compound it can, so I'm going to draw it just by itself in the compound, and oxygen has a 2- charge since it has 6 valence electrons. Alright? Okay, now I am going to cross my charges because that's the next step that I have to do. A lot of people forgot to do that on the test. Please don't forget. You've got to cross your charges. in order to create your compound. So what I'm going to create is Al2O3, and that's my product. Okay, that is a compound that is produced when Al and O2 react together. Now, if you notice, right now I'm almost done, but this is not balanced. Okay, so I've just got one more step to do. And if you're having trouble balancing, I've put up already a video explaining balancing on our class website, so you should watch that, all right? If this part doesn't make sense to you. All right, I've got one Al here, two Als here, so I need to put a 2 out front here. Okay, now I've got 3 O's here, but unfortunately I've got 2 O's here. Now remember in class I told you the easiest way to make these equal to each other is to make them equal to 6. Alright, so to make this equal to 6 I need to put a 2 out front. Alright, and I need to put a 3 out front here. Now if you notice, I've just messed up my number of ALs. Before I had 2, but now I've got 2 times 2, I've got 4. So I need to erase that. And now I have 4 ALs because 2 times 2 is 4. And now I'm done. So guys, using pencil for these is really, really, really important. Alright. I'm going to skip down and I'm going to work on number 3 with you really quickly. Alright, so I have aluminum. Al. So if I write it in words, guys, you've got to write out the symbols. So I've got aluminum reacting with, so plus, sulfur. Now I don't need to make these diatomic. They're not gases. They're fine. They're not any of my 7 diatomic elements. So they're fine all by themselves. Okay. Now my next task, before I decide what my product is to decide whether it's a 1A, 1B, or 1C reaction. So if you notice, okay, I don't have any water here, which 1B and 1C will require, so therefore it's still going to be a 1A reaction. Alright, now I have to create my product, so I've got Al. Remember, I've got to cross my charges, so I'm going to show this. If you can do this in your head, fabulous. Okay, sulfur, and sulfur has a 2- charge, so I'm now going to go and I'm going to cross my charges. So, now what I get Al2 for my product, S3. So if you notice, here's my product. I've taken 2 elements, made 1 compound. So this is obviously synthesis. All right. I now just have to quickly balance. So I've got 1 Al here, 2 Als here. So I'm going to put a 2 out front here. Okay. And I've got 3 sulfurs here. So I'm going to put a 3 here, and I'm done. All right. Let's look really quickly at water and dinitrogen pentoxide reacting. All right. So remember, whenever I give you words, please write it as a reaction. So I've got H2O plus, okay, as soon as you see your prefixes, guys, this is going to just be really quick and easy. N2-dinitrogen, O, pent is 5. Okay. So we first really quickly have to decide what type of reaction this is. 1A, is it just 2 elements reacting? No, I've got water in there. Okay. 1B, do I have a metal oxide, so oxygen and a metal? No, this is not a metal. This is a non-metal. Remember, right of the ladder is a non-metal. So I've got a 1C reaction. Okay, so in order to create these, what you do, I really love making the 1C reactions. I think it's really nice and easy. This is the only time that when making your compounds, you can balance in the act. All right, so the first thing you're going to do, since you're going to make an acid, the first thing that you put first is your hydrogens. Okay, so you've got H, and how many H's do you have? Well, I have 2. Okay, nitrogen comes next, your non-metal comes next. So I'm going to put my N. How many do I have of those? Well, I've got 2. Oxygen comes next. I've got 5 here, but 1 here. So I've got a total of 6. All right. Now, my last step, here's my acid. I can reduce this really nice and easily because all of these numbers are divisible by 2. So I'm going to reduce this, and I'm going to create HNO3 by dividing by 2, and that's my product right there. Okay, I just created an acid once water and a nonmetal oxide were combined. So here, this is the only time you can create your product while balancing. I had 2 hydrogens, 2 nitrogens, 6 oxygens. For any other type of problem, you cannot do that. Okay, so I like the nonmetal oxides because I think it's really easy because you don't have to balance afterwards. Let's look at an example of a metal oxide really quickly. All right, here's a metal, here's oxygen, and here's water. So you know you've got a 1B. You've got a metal oxide, and you've got water. So here's 1B. Okay? Alrighty. Now I know this is going to create a base. And remember, a base ends in OH. So I know that's going to be one of my products. And I know that a metal goes in front of that. So basically what it produces whenever you're creating a base, guys, you put your metal first. So I'm going to put Na first. All right, and I know that Na has a +1 charge. And then you put OH at the end because you've just created a base. So unlike your acid where you have H in the front, remember it begins with H, for your base it ends in OH. So with a metal oxide it creates a base. And if you look at this really quickly, those charges cancel, and so your product is actually just going to be NaOH. So it's actually pretty dang easy, I think. Okay, so make sure you're crossing your charges just like always. This one just ended up working out really nice and easily. Putting your metal first and then your hydroxide after it. Now my last step, unfortunately, yes, I do have to balance. So I've got 2 NAs here, 1 Na here, so I'm going to put a 2 in front. Now I have 2 oxygens here. If you look at this, I've got 1 oxygen here, 1 oxygen here. That's 2 oxygens. All right. I've got 2 hydrogens here, 2 hydrogens here. Remember, the coefficient is used for all of these now, and so I'm balanced. All right. So what I'd like you guys to do is complete the rest of this. Do number 2, 6, 7, and 8. If you're needing help, please come in. So pause this right now. Work on 2, 6, 7, and 8. All right, make sure you're crossing your charges unless it is a nonmetal oxide, and then you don't have to. But otherwise, you need to be crossing your charges and then balancing. All right. So you can pause this video right now. All right, I'm going to finish up really quickly. If you notice, oxides of metallic elements, okay, if you look here, here's a metallic element oxide. Okay, it creates a basic solution. Okay, with that OH. And then non-metallic elements. So here's your non-metal oxide, because nitrogen's a non-metal, and here's your oxygen oxide, creates acidic solutions. Okay. So your last task in this homework assignment, go through 4, 5, 6, and 8 and determine whether it's acidic or basic. Okay? Anhydride meaning without water. But look through these right now, okay? 4, 5, 6, and 8. Look at your products that you created and decide based on whether you have an OH or an H, whether it's going to be acidic or basic. All right? And that's the end of this video.